Well, welcome everybody. Uday and I've been hanging out for a long time, and I think this is a pretty good topic. This is something that I've been digging into personally lately, and thought I would share some of my learnings and findings. The talk is empowering AI agents with tools using MCP. So along the way, we're going to define at least a little bit what is an AI agent, because that's relevant here. What's a tool, and the MCP is a means to an end, of course. But first, quickly, I am various things. I'm a consultant, and I also co-run Boston Azure AI, which, along with New Hampshire Cloud and DevBoston, is another East Coast community group, and we also host in-person meetings and online events. So feel free to check us out there. And this is the topic as I published it. So I think it's useful to so this is the goal, right? By the end of the talk, you should understand what tools are, why AI agents benefit from them, and what role model context protocol plays, and how it solves problems. That's my goal. As Uday said, feel free to drop questions into the chat along the way, and maybe I can pause and answer some if they build up. But would also definitely time at the end for Q&A. Before we get into the talk, everybody knows Uday, and I think about marketing, and I noticed that in AI is becoming pretty popular. Uday himself is a pretty expert AI engineer, and I have a branding suggestion for you, Uday, is that you should start spelling your name like this. And that would fit right into.
That's awesome.
Okay, so that's my marketing contribution. So everybody will know you as an AI expert. Also, I'm going to post this deck, the one I'm in now. I've written some code that's on GitHub. I will post links to that. And I also have some external resources I'll point you to. I'm going to do a lot of this talk will be grinding through a few demos to give you a closer feel for a bit, rather than I don't have that many slides. And I'll put them all on blog codingoutloud.com probably tomorrow. Probably tomorrow. So that's where you can find it. Just so you know, everything's going to be available. So the trouble, started in November of 2025. When Anthropic, just out of the blue for most of us, they published this posting of news that they've open sourced their model context protocol, and I think it's useful to just start by jumping over there to that. So, sorry, this is the blog post I was mentioning. Interestingly, this is from Anthropic. A lot of my demos are actually through. I'm going to use the Claude for desktop because it's good. It's a good way to show off some of the MCP stuff. It was down for a few hours leading up to this talk, so I was trying to figure out what I was going to do for demo. Luckily everything's back right at the last minute. But this introduction to the MCP is what they announced. Specifications and SDKs, local service support, Claude desktop apps, that's what we're going to use today, and open source repository of MCP servers. So it's technology and a registry of who's offering MCP stuff. This is worth a read. I'll stick this in the resources, like I mentioned. Um, so for today, I'm going to talk about what is MCP. We'll do a lot of demos. We'll look at some code. Then we'll back off to a bigger picture towards the end with the agent to agent and Nanda to put MCP in a little bit more of a context. But for now, let's just go into look at a simple MCP server, and then we'll back up. We'll like look at it, and then we'll step back and say, well, what did we just see? Instead of talking high level and then getting into the details. I'm going to start with the details. So what I'm going to do is I'm going to open Claude Desktop. So this is a tool that basically you could just think about it as the Claude chatbot. It's more than that, but on your desktop for no particular reason, other than that gives you better integration with things like MCP. So you can ask it, who is president of the USA? And probably it knows. So that's fine. But you can also provide it with more powers than come in the box. And I'm going to do that first of all here. I'm going to bring in a sample here. So I have some images. I'm going to paste them in here. And I'm going to take this one here. And we're going to look, before I do Claude, I'm going to bounce back over to the browser for a second. That's this image. It's just a picture of a flower. And you know that you can, so this is a JPEG. You can change the file extension to JPEG and it still is fine. Do you know you can change it to a PNG and it's still, the browsers still interpret it, even though it's really a JPEG file and it's behind a ping. Won't work if you change it to like SVG. At any rate, I wrote some code that checks to see if the image is really legit. It resolves and its data type matches its extension. Is it really a ping? If it says PNG at the end, is it really a JPEG? So this isn't really the most interesting thing, the example, but the implementation is what we're going to focus on. Which of these are valid logo URLs? And I'm just going to let Claude Desktop handle that. Wait, we got a pop-up here. Claude would like to use an external integration, something called validate logo URL, and it points out, this is a warning you're going to see a lot. Review each action carefully before approving. Claude cannot guarantee the security or privacy practices of third-party integrations. So, okay. So since this is the demo, I'm not going to choose, you know, if you vetted this, you'd hit allow always. But because I want it to be a little bit in our face right now, I'm going to do allow once. And that means we're going to see this again. I'm going to say allow once. This is the second time. Third time. And there's a fourth time. So in the prompt that I gave to Claude Desktop, there were 4 different URLs that I asked it to assess. And that corresponds to the 4 pop-ups saying, hey, is this okay to run? And I said, yes, just this time. And this is the response that I get from Claude. After checking all 4 URLs, only one resolves to a valid logo. And that's this one. I actually, if I gave it the JPEG version too, that should have also been valid. But it identified these as invalid. Only one of them doesn't resolve. Example.org doesn't resolve. The other, or actually, SVG doesn't. SVG resolves too. Actually, there's a file there, but it's not a valid image file. So this is doing a little bit of logic. let's look at how I did this. First, let's look at the integration in Cloud Desktop first. And this is, let me do with the menus so you can see what I'm doing. I'm going to settings. I'm on a Mac, so there's a similar but not identical path for Windows or Linux. And I go to developer, and I've configured two model context protocol integrations here, two servers that I referenced. This one's called Logos, and it's just a little bit of configuration. I'm actually going to hit edit config, and I'm going to open this file. This is a just a JSON file on my file system, and it has a list of model context protocol servers that I want available to Claude Desktop. First one is called GitHub. The second one is called Logos. And this actually is running on my machine. It's in this this is .NET. In the project that it's running is on my local machine, also on my local machine under users build dev and so forth. And it goes down here to logo validator model context protocol. So we'll look at this. We'll look at the code in a moment, but I also want to talk about this. I have two servers running here. I have one that I wrote that, again, we'll look at the code too. One that I didn't write, I got off the internet from Docker. So it pulls this down off of Docker Hub and runs it. This one has to do with GitHub. So we're going to take a look at this too. Let's go back to the app. This is GitHub. And if I pop open advanced options, it'll show you my environment, which will show you my personal access token, which probably don't want to do in a recorded session. But let me show you how to set this up. So if you want to do GitHub, go back here. And if you read the documentation on GitHub, it's going to tell you exactly this. So there's nothing dramatic here. Here's my actual personal access token. I'm going to delete it. I'm going to go over to GitHub. And if you go to you go to github.com, find you, go to settings, and down here, developer settings, personal access token, and generate a new token, demo, and generate token. So the reason I'm showing you this is in part because I want you to realize that when I integrate this MCP server into my Claude desktop, I'm doing it as me. I'm giving it my access to my GitHub environment. So go back here, we paste in the token that we just created, and I'll invalidate this at the end of this session. But we'll go back. We have to restart Cloud Desktop. And so I have a GitHub repo called Cranking AI. So I'm going to ask it, this question here. Which GitHub repos did I create under the org Cranking AI in 2025 May? Dun, dun, dun. And get _ me. This is a method it's calling. This is a tool in terms of model context protocol. I'm going to say allow once. Now it's doing a search repositories. Again, I could do allow always, but I'm going to do allow once just to have these be on our face because we're doing a demo. And it found an answer. Logo agent. this is one we'll look at today. We'll look at actually logo validator, MCP, and Brave Search. So we'll look at actually all these. The images that we looked at are embed images. So here's some repos, but it performed a GitHub related action on my behalf inside of a chatbot because I empowered it to do so. Again, that was so GitHub we've configured, and logos we've configured. Doing okay. Feel free to drop questions in if they pop up. All right. So I wanted you to see it in action first. Now I'm going to go and have a closer look at it. So let's go to here.
There is a question if you want to answer. Where does the MCP tie into this? Is that the communicating protocol?
Well, I'm going to show you that.
Okay.
Yeah, exactly. So that's the point. So I wanted to provoke that kind of a question, like, what does MCP have to do with this? And we're going to do that by looking at some code here. So we have a project, very simple project. I'm going to get my examples mostly be in C#, but they don't have to be, of course. There's very good support out here in Python and other languages. But there's basically a program.cs, a console app in C#. And there's some boilerplate going on here. Some of this is just C#, .NET console stuff, like this stuff is. Oops. This stuff here, there's some libraries for adding, for saying, make me a model context protocol server and expose the tools in this assembly, which I'll show you in a second. And then with standard IO server as transport, we'll talk about that too. So this is so the model context protocol is implemented by this tool. This tool is exposed through model context protocol. Notice a couple of things. It has this is an attribute that is applied at the class level, and it says to expose this as a tool. Sorry, I don't mean to keep popping up that stuff there. And then within the class, I can have, so it's a collection of tools. Within the class, I can have as many tools as I need, and importantly, the tool has a description, checks whether the URL resolves to a valid logo, and has parameter names and a function name. So the description and there are other attributes you can put on this. The description is made available to an LLM. The logo URL parameter is made available to an LLM, and the function name, you can override this to give it a more clear name if you need to, is also made available to the LLM. And the idea with the model context protocol is that the LLM gets to call your code instead of you calling your code and passing the results to the LLM. So let's look at that a little bit graphically. So we already looked at that. Actually, let me start here. So a chatbot that we've all used, like I asked the Claude desktop what was who was the president, and it knows you're all used to chatbots where you can ask it a question, your question goes into the LLM, and you get a response out. And by the way, this isn't material really, but I'll point it out. When you do a chatbot, the LLM itself is actually stateless. So you're actually programmatically passing in the whole chat history every time. So that allows you to loop. That allows you to say, I'm traveling to Los Angeles, and what are some things I should do? And then the chatbot gives you a response. Then you say, are there any sporting events? And the are there any sporting events knows that the context is about Los Angeles because that's included in the chat history. You don't have to repeat that like you would in, say, a Google search. So there's the classic loop that you're all used to. But what happens when you have an agent is my impressive graphics here. The very definition of an agent is that you've given it some tools to use. Pause. This is a profound, these are bidirectional arrows, and then tools down here. So this in my mind is like an agent is it, let me go back here. So what is an agent? An agent is it has agency, it has a goal, and it's powered by an LLM. So you see both these in the diagram, and it has tools. That's, I think, the very definition of an agent. A goal is essentially a prompt powered by an LLM. There's all kinds of LLMs that can power an agent these days, and it has tools. So this whole focus of model context protocol is that it has tools. Let's go back here. So instead of this, we add the thing that distinguishes it from a chatbot, or one of the key things, is that it has the ability to call tools. And this is profound, so I'm sticking on this. An LLM makes the decision on its own to invoke a tool. An example of a tool is the GitHub tools that I showed a couple of minutes ago. Another example is one that checks a logo file for validity. Is it really what it claims to be, and does it resolve properly? Those are tools that you can give your LLM, and your LLM can be told it has a goal, given some tools, and it decides whether to call those tools. That's like a key thing. If it isn't deciding whether to call the tools, like you're just calling the tools programmatically, that's more like a workflow. And you can call tool, and then give the results to the LLM. But in an agent model, the LLM decides which tools to call. Like the super important point. And model context protocol basically says that we want a standard interface for calling these tools. So as and we'll talk about what that standard interface is. So as the idea of an agent, like we're talking about what is an agent here, there are lots of frameworks for building agents. Azure has a new one, a recent one called Azure AI Agent. There's a bunch of support in Azure AI Foundry. Semantic Kernel has a bunch of support for agents. And the interesting trend is that as we figured out what agents are, as agents become the central actor, everything is getting simpler in the code. We've been for a long time, for a year, say, in semantic kernel, for example, been able to have your LLM call tools. But the model that we looked at in the code there, that we'll go back to, is quite simplified. So it's simpler to define tools. That's why model context protocol exists, so that we can give the LLMs access to tools in a portable, standardized way. That's why it's Anthropic released a open source, their standard way of doing this. Microsoft's picked it up, OpenAI's picked it up, lots of vendors are picking it up. I wanted to point out this ground with Bing search thing too. So when we define tools that the LLMs can call, this is just an interesting thing I came across. With the Azure AI agent, there's another way to give it access to tools, which is like if you wanted to be able to have access to the internet, you could do that on the back end. You don't have to create a model context protocol server to provide it with search capabilities and some other things. So just found that interesting. You can look up this Bing grounding search resource approach. I had a problem. I was going to demo it, but I couldn't get. I don't have access to it yet. It's pretty new. You can run code in your Azure AI agent, in your AI agent, period. It can have memory, semantic search, RAG, stuff like that. But my point being here that as agents have come into focus, creating tools and making them callable by your LLM becomes the norm. It's not an exception. You don't have to configure it like you used to in the old days. You used to tell your LLM like, okay, now it's okay for you to call functions to invoke tools, and you'd pass it in as a parameter along with things like top P and temperature, max tokens, that kind of stuff. So it's becoming baked into it's a default behavior in an agent. A year ago, the agent abstraction really wasn't there. Now it's here. I also want to point out that prompt engineering is a thing that matters in agents, and it matters in your use of model context protocol. I'll show you that a little bit too. We have these. I'm not going to go through these, but there are a lot of prompt engineering strategies. Few shot, chain of thought, and so forth. These all still are around. But we get a few new ones with agents. And one of the interesting twists with agents is you need to tell it which tools it can call. And I think that's a double-edged sword. Again, we'll look at that in code in a minute. Architecturally, the model context protocol supports accessing tools in a couple of different deployment models. The one that we're going to use today is what we call standard IO. And that basically ends up running this GitHub Copilot. This is the example host here. Oops. And so GitHub Copilot can have a model context protocol server. In the demo I showed, this client was inside of Claude Desktop, but VS Code and others can do this as well. And it through the model context protocol, it loaded in that XML in that JSON file that I showed. There was a list of servers that it supported. One was related to GitHub, and one was related to validating that a logo was a URL pointed to a proper logo. And note that these both left the box. The GitHub one went out to called GitHub primitives on GitHub.com, and this one went out to the internet to validate that the files that are referenced, the URLs that are referenced, were valid. This one gives an example of one that we did not demo yet, and this is using model context protocol to a remote server. So the two that we showed run on the same box. The standard IO ones those are the ones we're going to stick to demoing today. They run on the same box, and the logic for calling, for doing whatever they do is basically in that local server. One was Docker recall, and one was just a straight .NET run. And then you can have another one that's HTTP or what's called server sent event SSE that is remote to your computer. let's look a little bit more at this. So I think it's interesting that there are a lot of MCP servers being curated. You're seeing these directories popping up, popular MCP servers. Some example servers, GitHub, we looked at that. AWS has a knowledge base thing going on. Perplexity, you can read these. There are thousands of these out there, and you can create your own and publish it as well. It's this is just one registry, mcp.so. We go over here, model context protocol.io. This is the official website from that Anthropic started. And this also has example servers. So you can see them from, there's some, one the other accesses your file system, some database related ones, Google Drive, GitHub, and so forth. So I think it's worth pointing out a couple of things. Like if we look at Raygun, oops. So I don't think this is from the company that makes Raygun. Usually looking at the license is a good way to tell. If we look at, let's say, Google Maps. Also not from Google. AWS knowledge base. Also not from, don't think this is from AWS. So my point being, or the thing that you should take away from this is, who are all these people publishing these servers? And that's a good question. We have, trust questions. And I'm still going more in the registry. He has another list of servers. These are reference servers. These, like this GitHub one, this actually is Microsoft, I believe. So there is one from Microsoft. I don't know if this is it, but you need to check. Yeah, before you start running somebody else's code. Okay, here are official integrations. Okay. These might be more aligned with the vendors. AWS Labs, yeah. So okay. So lots of people publish, lots of orgs publishing library, catalogs of all the model context protocol servers out there. And so you need to be careful whose you use, because there's a gap in the trust model currently. It isn't GitHub or Microsoft or Google or Amazon publishing all these things. His Playwright one, this is a browser automation tool used for testing. And just I thought it's worth pointing out, Microsoft has one, but somebody else has also cloned it, and they have their own very similar version of this. Probably it's fine, but in a corporation, how do you know that you can trust somebody who is a new vendor? People, right? Let's go. Okay, so let's pause for a second where we are. So model context protocol, it allows agents to call tools. Agents can invoke tools in a standard way. And at the end of the day, it's basically just invoking code. So you could, so if these are running on your computer, MCP server A on your computer, we talked about, can you really trust them? There's some things you can do. You can put it in a Docker container. The GitHub one that I ran came from GitHub, so I had some confidence anyway. But if it was from a third-party vendor, maybe it can't wreck my machine if it's running in a Docker container, but maybe it can send my data to places I don't want it to send it to, right? You have to think about these controls as you're adopting other people's services. All right. So the model context protocol talks about three sets of concepts: tools, resources, and prompts. This talk is going to focus on tools, in part because the community or the industry is focused on tools. Tools are things that you can invoke, like check this URL to see if it really points to a JPEG, or look up some stuff in GitHub on my behalf using my creds, or create a Jira ticket. That's something an MCP could do. Look up some more data, look in my database, my private company database, because an MCP tool can basically do anything that you can do by calling code. So it's just another API. It's anything you want it to be, called by your LLM, however. That's the big difference. Your LLM can invoke your CRM database or can create a ticket. So that's why we're sticking the tools. That's what that those catalogs have inventoried the tools. But the MCP standard recognizes two other kinds of interfaces that you can use MCP to retrieve. One of them is resources, and that's loosely data. Although there's some logical overlap, you could certainly use a tool to do data things, but it's separately modeled. And then prompts. These are basically what you think they are. These are, LLM prompts in, a reusable form. But again, neither of these seems to be getting a lot of traction quite yet, or at least compared to tools. So we're going to stick to tools. And then within tools, there are three communication approaches: standard I/O, SSE, and HTTP. The ones that we started to look at in code are standard I/O. And if you're an old school developer, you probably encountered back in the day that your application, your code, like a console app, would basically write its output to standard output. It would get user input from standard input. And if there was an error that it needed to emit, it would send that to standard error. And collectively, those are standard I/O. So these aren't new terms. I'm just pointing that out. These are ancient terms. The wire format, the way that your LLM and the client, the host and the client for your MCP server, the one that's talking to the MCP server, the wire format for that, between that and the MCP server itself running on the same machine in a different process, is basically JSON RPC, and again, over standard in and standard out. So your LLM can send a command or a query or whatever you're trying to do to the MCP host, MCP server rather, and then it will respond through standard out. So you send the running MCP server, its standard in is your host standard out, and vice versa, right? Because it's bidirectional. And then if there's an error in the Model Context Protocol server, it can emit that through standard error. There's an old, so I'm a little, there's some evolution going on in the second bullet here, the item 2. Server sent events were in the original spec, and plain old HTTP wasn't. But HTTP is now, there was a revision to the spec, I'm going to say last month. And so there's very little by way of HTTP, and there's a little bit of SSE. There's much less HTTP. And there's a lot of standard I/O out there. Thus, we're going to stick with standard I/O today. The standard I/O again runs on your local machine. The SSE and HTTP are executing external to your machine. This is SSE is a server sent event. Just a side note, when according to the spec, I believe it said it was stateful, which seemed odd because you really don't want a stateful server at scale. Generally, I don't know. Maybe they know something I don't know. But HTTP gives the newer HTTP approach provides a stateless model, which should presumably scale better. So this JSON RPC2 wire format, where does that come into the picture? So let's go back to the code. So these attributes here, these are part of a C# SDK basically for implementing Model Context Protocol. And notice that that I'm in this code, I'm not actually doing any JSON stuff. So I return a bool, is this valid or not? And the implementation of this just calls, this is like a little bit of a wrapper, a proxy you might call it, to an image validator class that's right here. It's not very complex. It basically say, hey, what kind of image are you? And usually images have magic bytes at the beginning. And if the bytes don't match, it says, well, this doesn't really look like a ping, and so forth. So, ping signature, for example. So it also makes sure it resolves, and then it returns, aye or nay as to whether it's valid. So this is just a straightforward, image validation class. No JSON going on here either. So all the JSON is baked into this these attributes in this big provided by the toolkit. So let's take another look at this code. So but by the way, right, very little code here. Like this implements a tool. I have basically surfacing my image validator, right? So this is going to be a very common pattern. You already have some code. You just want it to be easily accessible from an LLM. So you just expose it with this little wrapper.
So Bill, question for you.
Yep.
What is the major difference between, we were achieving this through kernel function, right? So now we're switching to the MCP server. What is the difference between achieving the same thing through kernel function versus MCP server?
Yeah. Let me come to that in 1 minute.
Sure.
I am going to show that. But so thank you for the question, Uday. And this is again, this is the dominant pattern that you're going to see with MCP. You already have some code. You just want to make it available to the LLM, so the LLM can call it. That's part of what being an agent is. The LLM gets to decide whether or not it calls one of your tools, one of your functions, one of your plugins, different terms for the same thing. Okay. And let's look at this in another way too. So when you have, let's go to another one of these. So we have, since my, the resource way of, that I alluded to of creating a resource for Bing search that your LLM, if it was an Azure AI, Azure AI agent approach could just have, didn't work for me. I had the screenshot of it failing. It's not available to my subscription yet. I created a model context protocol server for Brave search for no particular reason. And I'm going to show you another tool here that you're going to want to know. I'm going to show you a tool here that you're going to want to know about for developing model context protocol, which is their inspector. This is from Anthropic. So you run that npx. This is going to be the same for you, no matter what it is. And then these are similar to the commands in the JSON file within Claude Desktop, where it says to invoke this, you're going to use the tool .NET and the command run. And if there are more parameters, you can provide them. But you could also do this with Docker. You could do it with Python, JavaScript, whatever. But I'm doing it here for the model context protocol server that exposes the Brave search engine. So I'm going to now just click here, and this brings up, I'm going to connect, and it brings up the transport type, the standard IO. It's not HTTP or SSE, service sent events. This is the command and the arguments I use to launch it. And now I can do a list tools. So I just get search web. It's the only tool available. And I click that, and I can give it a query. And I can say Python programming tutorials. Run the tool. Now this is running the tool directly. It is not, I've decided exactly how to call the tool programmatically. This is not the same as the LLM deciding, but when the LLM decides to call it, this is how the LLM calls it. And it did in this search query and returned some results, result 0, result 1, result 2, and so forth. So you can test out your LLM, that your model context protocol server is actually functioning through this very handy tool. And if it isn't functioning, then it's not going to work through your LLM either. This is from standard error, and it pops up some messages here. We won't look at these, but they're there. And if you want to program your MCP server to output some debugging information, this is where it would go. So I'm going to disconnect from that. Go back here, and I'm going to go here, and let's run this. Whoops, I didn't mean to do .NET run. To do this whole thing. And let's run the same one for the image validator, the local validator. Let's go back to our website. Let's clear this tools. We got a different tool because we switched to a different MCP server, validate URL, and we had take our image here, and we can do JPEG, and it's exceeded, and it's valid, true. It's very simple, and has some logging output. You can see it down here in red. We could do the GitHub one, and it would have 20 tools listed. We're going to move on here. Let's go over to see if we can answer Uday's question. So let's actually disconnect and cancel there. So we're going to go over to the last demo, which is a logo agent. So this agent, let's look at it in code, is, again, not very complex. It's a main program, program.cs, which I guess there's a lot of lines here, but there isn't a whole lot of complexity here. So you need to load an LLM. You always need an LLM and an agent, right? So this is standard. Get me an API connection string, to an LLM. Configure the AI project client. This I happen to build with the Azure AI agent that I've been talking about a little bit. This was interesting, and there's a few lines there to create your AI project and Azure AI agent. And configure it. Nothing too crazy to see here. Then this is a standard semantic kernel thing. Nothing crazy to see here, except that it says, hey, any extra logging, send it to standard and concentrate all the logging through to the console. When I ported, I had a tool that was similar to the logo agent that I did with old school semantic kernel, and it had a bunch of debugging in it that wasn't going to standard error, and it quickly choked. And I realized that you had to treat standard output and standard input very carefully, and standard error had to be the place where your non JSON 2.0 RPC commands to and from had to go to standard error, or else you'll be confused with commands or responses. Create an MPC client for icon tools. This is the logo image validator that we've tested a couple times and seen. I'm going to invoke it here, and I have a similar launch commands. Of course, these would go in a real application. These would go in either a config file, or in the cloud. They would be in a settings service, something like that, be in the code. And we'll run this, and it'll show you the tools. We'll come back to that in a minute. And so here's one for the image validator. Here's one for the web search that I did with Brave web search. And again, all this code is available. So not, it's fairly boilerplate. This one passes in an API key. This one didn't need an API key because it doesn't have any privileged resources. And it's a couple of debugging statements like show all the available tools. You'll see that when we run it. And then, and Uday, in part, this is answering the question that you shared, which was, how does this relate to what semantic kernel would call a function or a plugin or a skill? All names that they've used. I think that mostly they call them plugins. There wasn't when semantic kernel started naming this stuff, there wasn't standardization in the AI world. So I don't think there still is, but again, semantic kernel calls them functions, but it calls them plugins. But it can add from a model context protocol function or tool, it can add that to the kernel plugins. So and that's basically what you do. you load your semantic kernel, you add to your semantic kernel all of the model context protocol functions, and it basically turns them into plugins. So this one adds the web search, the Brave web search, and this one adds the logo validation tool, the image validation tool. So it's these one-liners to idiomatic semantic kernel to do that. So the real answer to your question, Uday, is there's no difference. They amount to plugins in the end, and the only meaningful change is there's a different route to get them. So you can load anything from as long as it comes in through a model context protocol service, and you can make it a plugin, and it's available to the LLM, to the kernel, to make calls out to. And this is the interesting part. This is where the prompt engineering comes in, and just the fact that this is where the prompt engineering comes in is relevant. This is what they call the definition of an agent here. So, like I said, an agent in my mind is an LLM to drive it, a goal or mission or something that tells it what it's trying to accomplish, and then some tools to make that goal accomplishable. So in here, we're talking about a description and instructions. It has a name too. Oops, I'm going to change that back. I do a lot of experimenting. So the description is your diagnostic. Yeah, my apologies. I was playing with something there. So provides accessible HTML referencing the logo for technology, brand, etc. That's all it does. It says, hey, find the logo for this technology brand and give me a snippet of HTML that references it. Make it accessible, and then there's some more detailed instructions down here. You are an agent that provides accessible HTML referencing the logo for a brand. Let me make this a little bigger. Product or property. Usually a ping or a JPEG. I don't say SVG, but sometimes it comes back as SVG. Give examples like Python, semantic kernel, Java. And it's giving you instructions using the available tools to search the web, find the URL to a logo for the technology brand. Then using tools available, validate that the URL points to a valid logo. And then once you get through these two successfully, give as a response the logo image URL, a description of the logo. This is a unique part. I used to have a separate what would be today would be an MCP server tool that described the logo, but because I used a specialized LLM to actually do the vision part. But now we have multimodal LLMs everywhere, so it's easy to do this with the driving LLM. Although there are reasons that you might, we could talk about it. You might want to do it other ways, but basically, I'm asking the main LLM that's driving the agent to also use its vision features to describe the logo. And if you cannot find a logo at first, keep trying, but give up after 10 attempts. And always use the available tools for search. So one of the things that I think is bad about this is I have to do a lot of, I know this performs better, but it's unfortunate that I have to do a lot of telling it to use the tools. And I know it can perform even better if I actually give the exact names and descriptions of the tools in here. And that's coupling my prompts to my tools. So what if I want to evolve my prompting or my tools independently? I want to release an upgraded MCP server that maybe I've got cleaner wording on it. I don't really want to have to go and update all my prompts. So I hope that makes sense. If it doesn't, ask a question. because that's important. But you're coupling your prompts and your tools and your tool descriptions more exactly. So that's unfortunate. That's not. I think we can do better. But anyway, so there's the definition basically of what my agent's goals and behaviors are. And then I showed up above. I gave it two tools, two sets of tools, and the rest I think is mostly just debugging and boilerplate. So if I'll run it and I'll give it a brand. Okay, so mostly just boilerplate after that. So I'm going to do this .NET run, and I'm going to ask it to do the Python. Everybody knows Python. So let me tell you what the debugging statements are here. So connections 1, 2, 3. These are things in the Azure cloud. I dumped them out for debugging and visibility reasons. These are things in Azure AI Foundry. And then building the semantic kernel, built successfully. And then the first MCP server toolset has one available function it can call, validate logo URL. And the next one loads and it has one search web. Again, if I included the GitHub one in here, say, there'd be a list of about 20 tools that, things that GitHub can do. Seeking logo for Python. So all this was like debug stuff. And now now it's doing its work. This is the actual response from the LLM. And this is the money part here. This is in Markdown syntax, HTML snippet as asked. And it claims that this is a good logo for Python logo master version 3 trademark.ping. And this is also part of what I asked it to do in my definition of the agent. The Python logo, I asked it to describe the logo for like somebody who might have a screen reader so they can hear what the logo would look like if they could see it. Python logo featuring 2 intertwined snakes forming the shape of the letter P with the words Python next to it in blue letters. And of course, if we run this again, because it's an LLM, and we have a temperature and a top P that aren't 0, it will come up typically with a slightly different. So I don't know exactly what's different, but it's slightly longer this time. So the wording is slightly different here, and it shows a different logo. Oh, that's interesting. So we can look at those logos. And it came out with 2 different answers, but a valid logo in either case, one with a Python trademark and one without it. So this agent, whose job it was to come up with an accessible link to a logo for a brand, succeeded. All right. And I think, so this is most of what I wanted to talk about. I think I've shown you the inspector. So it's a useful tool for making, for testing out your running MCP. There's an example of an agent that uses a couple of custom MCPs. I've shown you how Claude Desktop can use MCP to supplement its capabilities, and VS Code can do that. In fact, VS Code will import from Claude, which is amusing. And I had just one more topic. I wanted to step back and look at the big picture. So let's quickly go through a couple of key points. Agents are getting easier and easier to build. I hang around semantic kernel, but there are no-code versions as well. Azure Foundry has some, and Microsoft has tons of effort going into low and no-code options for building them. Although, like I said, I'm hanging out in Foundry. and AI and semantic kernel. I talked about the prompt coupling, where if you want to evolve your model context protocol services and their names and their descriptions independently of your prompts, I think you're going to have a hard time. It won't work as reliably. But if you know you want to do ABCD, do it as a traditional workflow. Just write code to do it, as opposed to making it LLM driven. An MCP server is usually just a proxy to other code, and it can be any code that you want to write, and it's probably code you've already written. Access to your customer database, access to your, any system you have running in your company. MCP can get at it. Proxy, anything callable from LLM, hit a database, hit a cloud service, whatever. MCP is evolving. The standard IO model is popular, the most popular, and that's what most of the documented cases are. But HTTP and SSE are coming and growing. Security gets trickier. Who do you trust? And then at scale, we need more than model context protocol. We're not going to talk about these much, but I'm going to talk about them for a minute. And these these beg the question, like, how do you implement trust at scale, which is very interesting. So let me find where I put these. So Nanda I found out about this a few weeks ago at an MIT conference on distributed AI agents. And it's talking about Nanda stands for networked agents, and is the N, which is bothers me, but and decentralized AI. So they claim it builds on MCP to create a true internet of AI agents. So what's going to happen when you have and these are the kinds of problems they're trying to solve. What's going to happen when you have millions of agents that you can call, that you can invoke? There are thousands in these MCP registries, but give it some time, there'll be 1 million or 100 million. How do you discover them? How do you trust? I don't know if trust is written down here. How do you, is a human going to do all this work? Right, a human's going to look through the millions of MCP servers and pick them, or is this going to be an LLM-driven process? And if so, how do you pay for this stuff? So is the cryptocurrency, Bitcoin-like stuff going to get involved? Blockchains. How do you authenticate? Right. There's a whole other set of problems when, at least as Nanda sees it, at scale, which is such an interesting way to think about it. And then in the middle is A to A, which is agent to agent, which is a Google, initiative, and and they're working with Microsoft to Microsoft and Google and a lot of other players are looking to adopt the agent to agent protocol. There's a lot of ways a lot of one-off ways of doing it today. Like LangChain has a way. The AutoGen has a way of having agents collaborate. There's something in semantic kernel for this. There's the agent framework, and there's this process framework, and these all have something to do with how agents collaborate. So it's an interesting problem, and the Google 808 is, it looks like it might have the most chance of creating a standard. And I also wanted to mention this, the MCP C# SDK. This will be the last thing. So this is from Model Context Protocol organization on GitHub. It's not from Microsoft. It's not from, directly from Anthropic or anything. Microsoft and Anthropic, I think, collaborated on this. It's a good starting point. And it shows how to do some very simple MCP stuff. So it's not that hard to get started. Just a small number of lines of code in the simple case. And then you can test it out with the inspector. You can test it out with the Claude desktop. You can test it out with VS Code and so forth. So I'm going to stop there and take any questions that remain.
There are some questions in the chat window. I can unlock if you want to ask a question. Ralph, I'm going to allow your mic if you want to speak. The question is, how do we make it available to the LLM? We used to pass in the tools in the JSON to OpenAI. You mentioned that, but how are the MCP advertised to the LLM? I have more to this if I can. Okay, Ralph, you can talk. I unmute your mic.
So I can show you. So to make the model context protocol tools available to the LLM, at least in the semantic kernel context, you do two things. One is you load the MCP, connect to the server, and this is done through this this code here. What it's doing is saying, load this guy, and you give it a name. It's basically logo image. This is a name you make up for internal use in your agent. Tell it what command to run, and in this case, it's just the .NET command. And then you might give it some arguments. That's it. And this could be a Docker container, so it'll lead a little cleaner than this. You can also pass it parameters if you have to, like if you need to pass it an API key, you can do that. But that's one step. So you load it, and then you have it accessible, but your LLM can't call it until you do the second step, which is kernel plugins, add from functions, give it its name, same name as used above, and then this is an this is this here, like when you load the tools, and then you just say they use this link expression to say, hey, convert all these into semantic kernel functions, into semantic kernel functions, and make them available. So it's these two lines, these two snippets, one of these lines and one of these snippets. Half of this is debug code, like outputs stuff. This gets the API key. It's a lot of just plain old boilerplate here, but that and that would do it.
I can finally unmute.
Yeah, go ahead.
It enabled, so thanks, Uday. Thanks, Bill. I appreciate this. So you validated quite a bit of the things that I had already thought about because I read quite a bit of this. So just a comment and a question. I certainly see, the middle tier becoming prompt engineering, and that's getting away from code. And on that note, so I work for a large medical university with a medical side on it, and we have a chat bot, and it's not in C#, but it's in TypeScript, and essentially it's pretty complex prompt engineering. We have a lot of microservices that we talk to. Basically we gather everything up, and then we have our own Azure instance of OpenAI, and we pass it, there and back and forth, and that's how we do our chat. So my goal, and I started this week, was to actually try to see if we can integrate MCP instead of calling out to these microservices. So my thought was to, where we have specific logic and call microservices to get back, our JSON, and then, add to the prompt context before we send it over to OpenAI. My thought was to just go through and basically dissect, all these calls to the microservices, put them behind MCP, and then basically do what I was saying, right? Basically get rid of a lot of the code, if not all of it, and allow us to do prompt engineering to call the correct APIs in the end through MCP to get the same result. So just, is that idea realistic or not?
Well, there's quite a few details under there. But if you're so the MCP value, let me pop this back up here, is when you want your LLM to make calls to the tools. And there are a lot of cases where you don't want the LLM to make calls to the tools. For example, maybe there's something that happens every single time. Maybe it's a user lookup. Right? You have some identifier from the user who came in from the, maybe they're on a support web chat or phone or something, and you have some handle to them. You need to turn that into a customer record, right? You hit the database and you load some stuff. You could have the LLM do that, or you can do that before you invoke the LLM and you pass it in through the prompt. So the reason to pass it into the prompt is it's more reliable. There is some it sounds like you're getting your hands real dirty with the prompt engineering aspects of this, and as it's real work to get the prompts just right, so that the LLM works reliably-ish, right? But we're also in some aspects of this are non-deterministic. So if you're going to do it every time, though, right? I would call it and pass it into the prompt. But yeah, go ahead.
So the prompts are already complex, and my idea was, now we're adding another chatbot to another application within the organization, and we're coming across a problem of duplicating code. So my thought was to kind of extract those commonalities, and they were talking microservice, and I'm like, well, why don't we just throw MCP around it and just talk to it instead of going down the route of microservice, and we're still going to duplicate code and all that. So I wanted to just, we have our, our APIM environment, our gateway API, that you can look at it as Swagger, right? A million or, many endpoints. My thought was to just convert all that.
I would, so I'm reluctant to make sweeping statements, but what you say doesn't sound unreasonable. When I hear microservice, it also it rhymes with MCP tool. So
right.
It is a microservice. Let me just show you this too. If I go to agent mode, this is VS Code, and I look at my tools here. Let me just see. Okay, they're all selected. So and it didn't matter what I asked, but sorry, your request failed. Please try again. You may not include more than 128 tools in your request. I show this to this is a decision made by VS Code. I assume. I don't know if it's sensitive to the LLM. If I switch to Gemini, I don't know if I get a different response. No, same response. So I think it's a VS Code choice. But there's a limit to how many tools you can have. And it'll grow, just like the context window has grown the last couple of years from orders of magnitude. I assume the number of tools will grow. But as you get more tools too, you're gonna probably need to now anyway to tightly couple the tool names and descriptions into your prompts, causing unfortunate coupling. Anyway, so there's a limit. There's some complexity limits to how many tools you can have in flight. So I would factor that in.
Interesting. Okay. All right. I think that answered my question, so I appreciate it. Again, thanks, Bill.
You're welcome.
All right. Any other questions from anyone? So there is a description related question. Is the description the only clue to the LLM as to whether to use the tool, but also semantic of the args and semantic of the return value of side effect semantic?
Yeah, no, that's a great question. So the question effectively is like, how does the LLM know when to call a tool? And the ideal, I think, is your or is it part of it, like, or is it, semantics? The ideal is that entirely semantics, it will decide what to call. But what happens in practice today, at least, is you end up. Let me go to the. So the let me go to a. Here we go. This information here is what the LLM has access to. So it has the semantics and this. What people tend to do when they couple, if they want to work more reliably, is they take this text, checks whether the URL resolves, and they paste it into the description of the agent so that it's exact, right? Or they'll say something, check whether the URL resolves to a valid logo using the, and then they'll say, something like that. So make it very, very specific. So, so unfortunately, I think it relies on this wording more than I wish it did, but it still relies on it. What the LLM has to go by is its semantic understanding, this description, variable names. You can also have, we only show a couple of them here, MCP server tool description, but you can have a description for this as well. This is logo URL is pretty descriptive, so there's not really a need to supplement it with a longer description. But if you did do that with an attribute, the LLM would also have access to that. And it also has access to the name of the function, but you can also change the function name. Let's see, what would this be? There's another attribute you can use to change the function name, and it actually turns out that a better function name, I'll just call it function name. I don't know what it is off the top of my head. Is to use Python snake case. And apparently these, according to the big brains, these work better too, because there's been more training on this kind of stuff, AI training on Python naming conventions. So this will work, but this, from what I understand, will work slightly more reliably. And there's a I don't know what the attribute is off the top of my head, but there's one that would override this default name. So the answer to your question, I hope that answers your question. So it has access to all the stuff I just mentioned and the semantic context, and it tries to see if there's a match. And you might get different results, different runs. Even with the Python thing I ran, right? They get the logo. Got not only two different descriptions, but two different URLs are returned. So welcome to LLM land.
All right, great question. Thanks, Bill. Anyone have any other questions? I think we are right on times. The recording will be available less than 72 hours. The YouTube channel, and I will post the message on the meetup page.
Well, Uday, thank you for having me. Glad to come hang out with New Hampshire Cloud and DevBoston folks, and hope to see you all at other community events.
Yep, looking forward to see everyone in the future events. Thank you, Bill. I appreciate your time.